Good morning, it's Thursday the 21st of May. So, exercise I gave you to do yesterday was that one there. So we'll go through the questions. So the first one, question number 1. Use the y by dx to find the gradient of the tangent to the parabola y equals x squared at, and that was the 3 points. Now I gave you the wee clue by drawing that down. So we'll start off for A part 1. We've got y is equal to x squared, so the gradient of the tangent is dy by dx, so gradient is equal to dy by dx, and dy by dx for this curve is derivative of x squared is 2x. Now I only need to do that once because I can use that gradient for these 3 questions. So the first one for part 1, the gradient then is equal to x is minus 1, so it's 2 times minus 1, which is equal to minus 2. Now I want to just find the gradient of the tangent, so that's me, I'm done, it's minus 2. Second part, x is equal to 0, so the gradient is equal to 2 times 0, which is equal to 0, and that's that line there, gradient is 0, that's tangent where x equals 0. And the third part there is when x is equal to 1, so gradient is equal to 2 times 1, which is equal to 2. And I didn't draw that line in last day, so I'll do it now. There's the gradient where x equals 1, there's the tangent, so that there is the point x equals 1, and that's the tangent drawn there. Question 2, repeat this for the curve with equation y is equal to x cubed. Now remember that's the curve where y is equal to x cubed, so it's like a half a parabola there and it's twisted and it becomes up like that. Right, so we want the gradient of the tangent where x is equal to minus 1. So the first thing we're going to do is we're going to get the equation for the gradient of the tangent. So gradient of tangent is equal to dy by dx. And dy by dx for x cubed multiplied by the power, take 1 away from the power, is that. So when x is equal to minus 1, that gives me the gradient is equal to 3 times minus 1 squared. Minus 1 squared is 1, so the gradient is 3. Second part, when x is equal to 0, the gradient of the tangent to the curve is 3 times 0 squared, which is 0. And the third part there is when x is equal to 1, and the gradient would be equal to 3 times 1 squared, which is 3 times 1, which is 3. Now, I'll illustrate that in a sketch. So we want a line where x is equal to minus 1, so we'll say minus 1 is there, so there's a wee tangent drawn in there. When x is equal to 0, that's there, so there's a tangent just that's sitting on the x-axis, and when x equals 1, there's your other tangent. Okay, so that there would be x equal to 1, that would be x equal to 0, and this bit here would be x equal to minus 1. Okay, and you notice that that gradient and that one are exactly the same. Okay, next question, question 3. So for question 3, find the gradient and the equation of the tangents too. So a wee bit more work in these ones. So I'm going to go through them quickly. Gradient is dy by dx. So dy by dx for part A is going to be 6x. And it's the gradient when x equals 2. So when x equals 2, the gradient then becomes 6 times 2, which is equal to 12. Now I want an equation, so I really need a point. So I know that it's 2 something, but I don't know that y coordinate. But I do know that y is equal to 3 lots of x squared, which is 3 lots of 2 squared. 2 squared is 4, 3 fours are 12. So now I've got the point and I've got the gradient. I'll summarise that over here. And then we'll do the equation of the straight line, which takes us back to the first chapter. So we've got gradient is equal to, we've worked it out as 12. And we have got the point 212 for the line of the tangent. So y minus b is y minus 12 is equal to m times x minus a. So therefore y minus 12 is equal to 12x's minus 24. I want to add 12 onto both sides, so y is equal to, missed out a wee x in there, is equal to 12x's minus 24 plus 12 is minus 12. Okay, 5 part B, so y is equal to x squared plus 2x, and we want to find out the equation of the tangent where x is equal to 1. Right, I'm going to start and just get the equation, the point, first of all, the y-coordinate for that point. So the y-coordinate when x is 1 is going to be 1 squared plus 2 times 1, which is 1 plus 2 is equal to 3. So that's me got the point. Now I need the gradient. So the gradient we know is m, and we know it's dy by dx. So dy by dx, take the derivative of x squared is 2x, and the derivative of 2x is plus 2. Now I want the gradient when x was equal to 1. So at x equal to 1, gradient is equal to 2 times 1 plus 2, which is equal to 4. So now I know gradient is equal to 4, and the point on the line is 1, 3. So the equation is y minus b is equal to m times x minus a. So y minus b is y minus 3 is equal to 4 times x minus 1. So y minus 3 is equal to 4x is minus 4. So y is equal to 4x, and add 3 onto both sides is minus 1. Okay, 3 part C. So we've got y is equal to x to the power of 4, and it's at x equal to 1. So I'm going to do the point first of all. So I've got the point 1 something. I want to work out the y coordinate. So it's 1 to the power of 4, which is also 1. Now I want the gradient. So the gradient is equal to dy by dx. So go back. Dy by dx is equal to multiply by the power, take 1 away from the power. Now it's at x equal to 1. That's what they asked me to do, x equal to 1. So the gradient is 4 times 1 to the power of 3. 1 to the power of 3 is 1. So 4 ones are 4. Right, all information is there. All I have to do is get it all together. So gradient is equal to 4. And the point in the line was 1, 1. So y minus b is y minus 1 is equal to m times x minus a. So y minus 1 is equal to 4x is minus 4. So y is equal to add 1 onto both sides, 4x minus 3. Okay, so y is equal to, for part D, the square root of x. But x, the square root of x is also x to the half. Okay, now I want to work out the point. So the point where x is 4, so it's 4 something. Now, this is the one I'm going to use where it shows me the root. So the y-coordinate is the square root of x, which is square root of 4, which is 2. So that gives me the point 2. Now I want the gradient. So gradient is dy by dx. And that's why I've got to change it to a power of x. So it's x to the half. So the derivative is multiplied by the power, take 1 away from the power, which gives me that. Now I've got to substitute a number in here. So I'm going to tidy this up. Change to a positive power. So take that down to join that 2 at the bottom. And we know that anything x to the half is the square root, so it's 1 over 2 times the square root of x. Now, the gradient at x equal to, we want the gradient x equal to 4. So when x equals 4, then we substitute 4 into that, and we can get the value for our gradient, so x equals 4. Right, so that is going to be, in this case, it's going to be 1 divided by, and that's going to be 2 times square root of 4. Square root of 4 is 2, so it's 1 over 2 times 2, which is a quarter. Okay, get all our information together. So gradient is equal to a quarter, and the point on the line was a 0.42. So y minus b is y minus 2 is equal to a quarter times x minus a. Don't like quarters, so I'm going to multiply everything by 4. So 4y minus 8 is equal to 1 lot of x minus 4. So 4y minus 8 is x minus 4. Add 8 onto both sides. So 4y is equal to x plus 4. Okay, next one, part A. Y is equal to x to 3 over 2, and we want to find it at x equal to 1. Okay, so we'll start off by that's in the correct format to take the derivative of, but I want to work out what the y coordinate is for this point. So it's 1 something. So y is equal to, I want to change that to roots and powers. So the 2's at the bottom, so it's the square root of x to the power of 3. So it's going to be the square root of 1 to the power of 3. Square root of 1 is 1. 1 cubed is also 1. So the point we've got is 1, 1. So gradient is dy by dx. And for the gradient, we want to use this format. So multiply by the power is 3 over 2, x to the power of take 1 away, so 1 is 2 halves, so it's to the power of half. Now I've got to substitute numbers in there, so we don't want fractional powers, so that's the same as 3 over 2 times the square root of x. Now I want to work this out when x is equal to 1, so therefore the gradient is equal to 3 over 2 times the square root of 1. Square root of 1 is 1, 3 ones are 3, so it's 3 over 2. So gather information, gradient is equal to 3 over 2 and the point on the line is a point 1, 1. So y minus b is y minus 1 is equal to m times x minus a. Multiply by 2 to get rid of those fractions, so 2y minus 2 is equal to 3 lots of x minus 1. So 2y minus 2 is equal to 3x's minus 3. 2y is equal to 3x, and we want to add 2 onto both sides, which gives me minus 1. Okay, next one, y is equal to 1 over x squared, and we want to work all this out when x is equal to minus 1. So, gradient of tangent to a curve, we need the point, so the point is at 1 something. They haven't told me the y coordinates, I need to work it out. Now I'm going to use that to work it out. So y is equal to 1 divided by 1 squared. 1 squared is 1, so that's equal to 1, so it's 0.11. Gradient is dy by dx. So the gradient for dy by dx for that one is, we use this format with the x's at the top. So multiply by the power, take 1 away from the power is minus 2x to the power of minus 3. I'm going to have to substitute in a number. So we don't want negative powers, so it's minus 2 divided by x to the power of 3. So gradient at x equal to 1 is going to be, gradient is equal to minus 2 divided by 1 to the power of 3. 1 to the power of 3 is still 1, so it's equal to minus 2. So gradient equals minus 2, and the point in the line is 1, 1. So y minus b is y minus 1 is equal to m times x minus a. So y minus 1 is equal to minus 2x's plus 2. Add 1 onto both sides. So y is equal to minus 2x's plus 3. Okay, next one, y is equal to 16 minus 3x squared at x equal to minus 2. So x is minus 2. I want to find out the y coordinate. So y coordinate is going to be 16 minus 3 times minus 2 squared. So that's 16 minus 3 lots of minus 2 squared is 4. 3 fours are 12, so it's 16 minus 12, which is equal to 4. Right, so we've got the point, and now we need the gradient. So gradient is equal to dy by dx. So dy by dx, we've got to take the derivative. Derivative of 16 is 0. Derivative of minus 3x squared multiplied by the power, take 1 away from the power, is minus 6x. Now the gradient at x equal to minus 2, gradient then will be equal to minus 6 times minus 2, which is going to be equal to 12. So gradient equals 12, and the point on the line is point minus 2, 4. So y minus b is y minus 4 is equal to m times x minus a. 2 minuses make a plus. So y minus 4 is equal to 12x's plus 24. And we want to add 4 onto both sides. So y is equal to 12x's plus 28. Okay, last one in the exercise. We've got y is equal to x minus 1 all squared. Cannot take the derivative of brackets, so at some point we're going to have to multiply that out. However, I want to work out what the point is first, so it's 1 something. I can leave it in that form. So the y is equal to x minus 1 all squared. So it's 1 minus 1 all squared. 1 minus 1 is 0. 0 squared is equal to 0. Okay, so it was okay to keep it in that format to get the point, the y coordinate of that point. Now for the gradient, I need to multiply it out. So the gradient is x minus 1 all squared. Well, not the gradient. Y is equal to x minus 1 all squared. So we need to multiply this out first. Square the first is x squared. Square the last is plus 1. Multiply the two of them together and double it is minus 2x's. Now I can work out the gradient, which is dy by dx. Okay, so gradient is dy by dx. And it should be okay to do that now. So it's 2x minus 2. And the value they gave me was for x was equal to 1. So your gradient is equal to 2 times 1 minus 2. 2 ones are 2, take away 2, gradient is equal to 0. Right, gather our information together, so gradient is equal to 0, and it passes through the point 1, 0. Right, big alert here. When a gradient is 0, you have got a horizontal line. Now, think back to chapter 1. What was the equation of a horizontal line? It started off with y is equal to a number. Okay, if you've got one point in the line, what's the y coordinate? The y coordinate is 0, so it's y is equal to 0. That's the tangent, the equation of the tangent to the curve at that point. Okay, so that last one was a wee tricky one, so watch out for them. Okay, we'll now go on with our lesson. Okay, just a wee bit of notation, so it's nothing new. Notation for finding the derivative, you can have d by dx and then what you want to take the derivative of written in a bracket. And if it's written like that, you can just write equals and take your derivative, so 6x minus 2. Now, that means, not really, but it's how I say it is and how I pass on to you what you're doing. You're doing the x's, you're doing the t's, you're doing the u's. So, doing t's, you can go on and write it down. So 3 5s are 15, t to the power of 2. Derivative of that, a half of 4 is 2. 2t, take 1 away from the half, is minus a half. And that last wee one, not in the correct format to take the derivative, so just change it. Keep this du at the start, change that to bring your u up to the top is u to the minus 2, multiply by minus 2, so minus 2 times 3 is minus 6, 4 stays at the bottom, so it's minus 6 over 4 u to the minus 3, and change it to positive powers and cancel down is 3 over 2, the minus sign is there, and bring your u down to the bottom. Okay, last example, we've got to find the angle between OX and the tangent to the curve at the point x equals 2. Right, now you haven't seen this for a wee while, but hopefully you'll remember, as soon as you hear something about the angle between OX and the positive direction of the x-axis, then what's that talking about? It's talking about tan theta. So it's telling us that the gradient of the tangent is equal to tan theta. Okay. Right, so gradient of the tangent we know is m, and it's equal to dy by dx. So dy by dx for this one is going to be minus 6x to the power of 1, which is minus 6x, and 10x, the derivative of that is plus 10. So we want this at x equal to 2, so the gradient is going to be minus 6 times 2 plus 10. So minus 6 times 2 is minus 12. Minus 12 plus 10 is equal to minus 2. So the gradient is minus 2. I want to work out the angle, but I know that tan theta is equal to minus 2. Now I want to solve that equation. So calculators out, and you do tan to the minus 1 of this minus 2. So gradient is equal to tan to the minus 1 of minus 2. Now, I'm going to just stick that into my calculator as it is. When you put that into your calculator, you get minus 63.4 degrees. Now, what that means is there's the x-axis, and this gradient of a tangent is coming down here. Not drawing it in the right orientation, I'm going to read. Okay, this is better. So there's the x-axis, and what it means is there's your equation, there's your tangent, and it's coming back that way by 63.4 degrees. Okay, and we know that because it's minus. So really I want that angle in there. So all I do is add 180 onto it, and it'll tell me what that is. So the angle in there is angle theta, which is equal to 116.6 degrees. Now, this is the last one I'm going to do here, and it's a gradient back to front. Okay, so this is the only other way this can be asked. It says at what point on the curve is the gradient of the tangent 2? So the only thing you know about the gradient of a tangent to a curve is it's dy by dx. So the gradient is equal to dy by dx. So what is dy by dx? It's going to be 6x squared minus 4. So that's the gradient of the tangent. Now they're asking me to find at what point, so that really is, I want to work out the x number and subsequently the y number. But they're telling me that this gradient of the tangent is 2. So they're telling me that 6x squared minus 4 is equal to 2. So now I've got a wee equation I want to solve to find out what the x number is. So I'm going to make all to give me 6x squared and add 4 on both sides is equal to 6. So 6x squared is 6, then x squared must be 6 divided by 6 is 1. Now this is where you've got to be careful, because x squared is 1. What does that mean x is? X could either be 1 or x could be minus 1. So there's one point here that's 1 something, and there's another point that's minus 1 something. So what do we know about y? So y was equal to 2x cubed minus 4x. So y is equal to 2x cubed minus 4x. So when x is 1, then that's going to be 2 times 1 to the power of 3 minus 4 times 1, which is 2 minus 4, which is minus 2. So that's one of the points. And the other point is when x is equal to minus 1. So y is equal to 2 times minus 1 to the power of 3 minus 4 times minus 1. Minus 1 to the power of 3 is minus 1, times 2 is minus 2, and that gives me plus 4. So 4 take away 2 is 2. So there's actually 2 points on this curve where the gradient of the tangent was 2. Okay, so just a wee recap in that one. So if I ask you that, you're going back to the front when you're finding the point, you're finding x. So you take your derivative to give you the gradient, you set it equal to 2, and you solve that equation to work out what x is. And then you work out what the y coordinate is using that one. Okay, so we've got through quite a lot today. So I'll give you your exercise on that. So what I want you to do is, I want you to do that exercise there. So questions 4 up to question 8, and that is for Thursday. What I should have said is, this is Thursday, it's for Friday. Okay.